Let's take a look at related rates of change. So that's when we have to find two or more rates and link them together to solve our problem. So basically it's our chain rule, implicit differentiation, call it what you will. They're all the same thing under different names. An HSC question from a few years back. A stone drops into a pond, creating a ripple. And so obviously the ripple starts with a radius of 0 centimetres, and then once the stone drops into the pond, that radius will grow. So we want to find dA dt, the rate at which the area of the ripple is increasing. Now they've given us some information. They've told us that dr dt is equal to 5. So if we can come up with a relationship between A and R, which of course we have, we should be able to solve this problem because dA dt will be dr dt times dA dr. Well, of course, the area of a circle is pi r squared. So dA dr is 2 pi r. Let's sub into our equation. We get a new formula, and dA dt is 10 pi r. They want to find out when the radius is 15. So sub in 15, and we get 150 pi. So the ripple's area would be increasing at a rate of 150 pi, and that would be centimetres squared per second. 2018, we have this Ferris wheel, and they've told us the radius and its rate of rotation. First part, simply just have to show that dh to theta is 20 cos theta. So if we have a look at that right angle triangle that's been drawn for us on the Ferris wheel, we can see that h over 20 is sine theta, h is 20 sine theta, differentiate with respect to theta, 20 cos theta. So that's the first part of the question. They now want us to find out at what speed the top of the carriage is raising when it's 15 metres above the diameter. Okay, so dh to t, how is that height changing? We just worked out dh to theta was 20 cos theta. We also know the theta to t is 1.5 metres per second. Well, I've turned that into a fraction, so I've got 3 on 2. So dh to t will be dh to theta times the theta to t, sub in, and we get a formula that dh to t is 30 cos theta. Now we don't know what theta is, but we don't need to know what theta is. We only need to know what cos theta is. Now when h is 15, and here's my triangle, the radius isn't going to change, that's going to stay at 20. So when it's 15, then the adjacent side will become root 175. So cos theta will be root 175 on 20, so dh to t will be 30 times that. They want the answer to 1 decimal place, so 19.8 metres per second. And one from last year. Distance A is inversely proportional to distance B. So A is equal to 9 on B. And the two distances vary with respect to time. And they've told us the rate of change of B. They want us to find the rate of change of A. Okay, so we want to find dA to t. They've told us dB to t is 0.2. And again, I've changed that to a fraction, so 1/5. A is 9 on B. Let's differentiate. Okay, so dA to t equals, now 9 on B, I can't differentiate it with respect to t, so I'll do some implicit differentiation here. Differentiate it with respect to b, I get minus 9 on b squared, but now I have to multiply it by dB to t. So when A is 12, we know B is 9 on 12, we can work that out. So subbing all the values in, and we get minus 16 on 5. So I'll put it back in the decimals now because their question was in decimals, so I'll give the answer in decimals. So decreasing because it's negative, but at a rate of 3.2 metres per second. Okay, so 9E, playing with this idea of related rates.